When converting between rectangular and polar coordinates, we need to sort of maybe have a picture in mind and remember some of our properties of trigonometry. So remember that what we now have is we have two kinds of systems. And I'll go ahead and put the rectangular coordinate system, let's say we have x and y, and we may have a point out here, somewhere out here in the plane. This point in the rectangular coordinate system is represented by a number for x and a number for y. And remember that in that system, what you do is you start at the origin, you move to the left or right a distance, and that's x, and then you move up or down as the case may be, and that's your distance y, and that brings you to this point. Now, if we superimpose or put on top of the polar coordinate system, now instead of calling this the origin, we call it the pole, and we no longer have an x and y axis, but simply a polar axis. In the polar coordinate system, we stand on the pole and we look down the polar axis. Then we rotate until we are facing the point that we want to move to, and so we call that angle theta. We're still at this point, we're standing at the pole, but now we're looking down that line towards the point. Then we actually travel from the pole out directly to that point. And so this point is a distance of r away from the pole, and the point is represented by the polar coordinates r comma theta. So then the question becomes, if you are given, for instance, you're given a set of polar coordinates, 3 pi over 4, what is the equivalent set of rectangular coordinates that would get us to the same point in the plane? So how to convert to rectangular coordinates? Well, for rectangular coordinates, we simply need to know the x and the y coordinates, and then we have those coordinates. So we need to figure out what x is and what y is. Well, for that, again, we can use a bit of trigonometry here. Notice that we have a right triangle. Here's our right angle. And we have an angle theta, and we have the three sides of the triangle mapped out. If we draw it all in green, we're quick to realize we have a right triangle. So we can write down some equations. So for instance, we could say the cosine of theta equals, in terms of a triangle, the cosine is the adjacent, which in this case is x, divided by the hypotenuse, in this case is r. So cosine of theta is equal to x divided by r. If you multiply both sides of the equation by r, you get that x is equal to r cosine of theta. Similarly, we could look at our triangle again. We could write another equation. We could say the sine of theta. Sine of theta is opposite, which in this case is y, divided by the hypotenuse, which again in this case is r. And if we multiply both sides of the equation by r, we have y is equal to r times the sine of theta. So once we know what r and theta are, we can use these two equations to find out what x and y is. So for our point 3 comma pi over 4, so convert 3 comma pi over 4, convert to rectangular coordinates. 3 comma pi over 4, x is going to be equal to r cosine of theta. R is, in this case, 3, so 3. Cosine of theta, theta is pi over 4. The cosine of pi over 4 is the square root of 2 over 2. So x here is equal to 3 times the square root of 2 divided by 2. Y is r times the sine of theta. R times the sine of theta, r is 3. Sine of theta is still pi over 4. Sine of pi over 4 is also square root of 2 over 2. So in this case, x and y are the same. They're both 3 square roots of 2 over 2. So what is the set of rectangular coordinates that corresponds to the polar coordinates 3 and pi over 4? It's 3 square roots of 2 over 2, 3 square root of 2 over 2. So there's an example of converting from polar coordinates to rectangular coordinates. Well, we can also go the other way. If we need to know, if we have the rectangular coordinates, let's say we have the rectangular coordinates xy equals, I don't know, let's say 1 comma square root of 3. And we want to convert, so how to convert to polar coordinates. Well, we can again look at our picture and we can remind ourselves of some equations that we have regarding this picture. Notice here that we do have a right triangle, and the Pythagorean theorem tells us that r squared, the hypotenuse, is equal to x squared plus y squared. So once we know what x and y are, we can find r. We can solve for r. Also, we can find theta depending on x and y as well. We know that for a right triangle, the tangent of theta is equal to the opposite, which in this case is y, divided by the adjacent, which in this case is x. So the tangent of theta is y over x. So to convert from rectangular coordinates into polar coordinates, we can use these two equations. R squared equals x squared plus y squared, and the tangent of theta equals y over x. So let's see that for this one point, x equals 1 comma square root of 3. So convert to polar coordinates. 1 square root of 3. Again, we need to find r and theta. R squared equals x squared plus y squared. So r squared in this case is 1 squared plus the square root of 3 squared. R squared is 1 plus 3. So r squared is 4, which means that r is plus or minus the square root of 4, which is plus or minus 2. Now we do have some flexibility as to what we choose for r. Remember that the distance could be either positive or negative. Typically, however, we pick, when we're converting from rectangular coordinates into polar coordinates, we pick the positive r, the positive distance. So let's take r to be equal to 2. Now we need to find out theta. So we have our other equation. The tangent of theta is equal to y over x. So here, the tangent of theta, y is equal to the square root of 3, x is equal to 1. So tangent of theta is equal to the square root of 3. And if you remember back to your unit circle, that is going to be some variation of pi over 3. So in fact, it could be, if you think about tangent, remember, is y over x. So y over x, square root of 3 divided by 1, they're both positive. So we're either in the first quadrant, where we have, say, 1/2 square root of 3 over 2, or we're down here in the third quadrant where they're both negative. -1, negative 1/2, negative square root of 3 over 2, if we're on the unit circle. that's where the tangent is equal to the square root of 3. So this angle would be pi over 3. This angle would be 4 pi over 3. So we have to know which one of them is actually correct because they both have the tangent equal to square root of 3. Here's where we have to go back a little bit and see where was our original point. Our original point, both coordinates are positive, so this is in quadrant 1. Which tells us that our angle now, since we've taken r to be positive, our angle must be pi over 3. So our set of polar coordinates is, what was our radius? 2, and our angle, pi over 3. So there is a conversion from rectangular coordinates to polar coordinates.